Welcome to this explainer. Today, we're going to demystify the completely overwhelming AI landscape. Seriously, it's a lot, but we're going to break it down with a clear chronological learning roadmap. It's designed specifically for complete beginners so we can finally figure out how all these crazy buzzwords actually fit together.
So let's just dive right into this by asking a pretty simple question. How does the everyday magic on your phone actually work? From securely unlocking it just by looking at it with Face ID to predicting your exact arrival time in bumper-to-bumper traffic with shocking accuracy. What is actually going on under the hood there? Well, all these features are powered by artificial intelligence, and AI is simply technology that allows computers to perform tasks that typically require human intelligence. Think about it. We as humans are naturally great at looking at data and finding patterns, right? Or hearing speech and understanding the context. AI basically applies that exact same human-like intelligence to computers. It allows a camera to analyze the numbers on a speeding car's license plate and automatically issue a traffic ticket without a human ever having to lay eyes on it. To turn you from an AI novice into a totally informed user, we're going to climb a 5-step learning ladder today. We'll hit machine learning, the types of ML, deep learning, generative AI, and finally, NLP and LLMs.
Let's start right at the foundation. Step 1, machine learning, the core of AI. This is the foundational subdomain that powers the vast majority of the AI we interact with every single day.
Now, there has been a massive paradigm shift in how we solve problems with computers. In traditional computer science, you write a program, you give it an input, and it spits out an output. Boom, simple. But looking at the machine learning side, it's completely flipped. Instead of hard-coding the exact logic, we feed the machine learning algorithm the inputs and the desired outputs. And get this, it actually figures out the logic all by itself. That generated logic, that's what we call an ML model. It's a real game changer.
So, you might be wondering, how does a model actually come to life? Well, it happens in 2 primary steps. Let's say you want to automate bank loan approvals. First, the system goes through training. It literally consumes massive amounts of past applicant data to learn the hidden patterns of who got approved and who defaulted. Once it's learned those patterns, it moves to step 2, which is called inference. Here, the trained model uses its newly formed logic to make fresh predictions on brand new applicants.
Moving on to step 2, types of ML and how models learn. Now, what's really interesting here is that machine learning isn't just one big monolithic thing. It's actually divided into 3 distinct categories, based entirely on how the model learns. Those 3 learning paths are supervised learning, which relies on neatly labeled data, unsupervised learning, which blindly searches for patterns in completely unlabeled raw data, and reinforcement learning, which operates on a system of rewards and penalties. These 3 completely different paths dictate exactly how we format our data and what kinds of real-world problems we can actually solve.
To see how this actually maps to the real world, think about your inbox. Supervised learning helps Gmail filter your spam because it's been trained on millions of emails clearly labeled as either spam or not spam. Unsupervised learning, on the other hand, blindly groups related news articles together just by finding similarities in the text. Nobody labeled them first. And reinforcement learning, that trains self-driving cars through trial and error. Honestly, it's genuinely just like training a dog with treats. The AI agent gets a reward for staying in the lane and a penalty for swerving, constantly maximizing its score until it masters driving. Next up is step 3, deep learning and neural networks. You see, when traditional machine learning struggles with really messy, unstructured data, we're talking millions of video pixels or raw audio recordings, we absolutely must step up to this 3rd rung of our ladder. Deep learning is entirely driven by neural networks. These are intricate systems of hidden layers, directly inspired by the neurons in the human brain. They specialize in extracting information from raw, unstructured data. So instead of you trying to program what a human face looks like mathematically, which is basically impossible, a neural network can analyze a picture pixel by pixel, layer by layer, and extract the defining features of an eye or a nose entirely on its own. The way these networks learn is just absolutely fascinating. Think of it kind of like a student taking a test. In step 1, forward propagation, the network takes a guess based on assigned mathematical weights. Then, in step 2, backward propagation, it essentially gets graded, realizes its mistakes, and goes back to study harder. It tweaks those mathematical weights up and down until it gets an A+. Now we arrive at step 4, generative AI and synthesizing new data. Honestly, this is where the magic really happens, because the system stops merely predicting outcomes and starts synthesizing brand new material.
This is a massive shift from simple analysis to actual creation. Instead of a deep learning model just looking at an image to tell you if it's a cat or a dog, generative AI tools can actually paint a brand new, highly realistic picture of a cat for you, right from scratch. It is generating entirely new text, audio, images, and video based on the patterns it learned during training.
You are likely familiar with the heavy hitters here, which cover a massive spectrum of creative tasks. You've got ChatGPT, Claude, and Gemini acting as textual chat assistants, Midjourney and Dall-E creating just absolutely stunning images, Sora generating Hollywood-style video clips, and GitHub Copilot writing complex code. And the craziest part? It's all done from simple human prompts.
Which brings us to step 5, NLP and LLMs, or language processing. To truly understand how those text-based chat assistants we just mentioned actually work, we have to tackle this final foundational rung on our roadmap.
Natural language processing, or NLP for short, is the broader domain dedicated to teaching a machine the nuances, context, and meaning of human languages, like English, Hindi, or French. It basically takes a messy human sentence and turns it into tokens and mathematical contexts that a machine can actually process and understand.
And the specific engines solving these language tasks today, those are large language models, or LLMs. These act as the literal brains behind the chatbots we use on a daily basis. They're a specific type of deep learning architecture designed entirely around predicting the next logical word in a sequence based on vast amounts of context.
And they definitely earn the word large. Why? Because they contain billions or even trillions of parameters. To put that into perspective, imagine having to read the entire textual history of the internet, every article, every book, every weird forum post, just to learn how humans talk. Well, that's exactly what these models did. They mapped out word relationships so precisely that they appear to actually understand us when we speak to them. It's mind-blowing.
So there you have it. You've successfully climbed the entire foundational ladder, from the basic logic of machine learning all the way up to the creative synthesis of LLMs. The only question left is, are you just going to be a passive consumer of this technology, or are you ready to start building the future yourself? The roadmap is entirely yours.